Hello everyone, welcome to this next session of your open channel flow. So today we are here with the English class for your open channel flow most expected PYQs. So revision through PYQs we are going to do. The subject is your open channel flow and we are going to do the revision through PYQs. So let's see what we are going to do today. So we are going to have some very important PYQs of previous year. So let's start solving from this question. So I think each and everyone has joined and my voice and video is clear to everyone. So please first confirm whether my voice and video is clear or not so that we can continue. Please confirm whether my voice and video is clear or not so that we can continue. Okay, so now your chat is visible. Okay, as I can see, voice and video is clear. So please solve this question. This question has been asked in GATE 2008 in civil engineering for 1 mark. And it is saying a person standing on the bank of the canal drops the stone on the water surface. He notices that the disturbance on the water surface is not traveling upstream. This is because the flow of the canal is. So the water surface, the wave is traveling, but wave is not traveling upstream. First is wave is not traveling at all. First thing is that wave is not traveling at all. So for that you will have the critical flow. But it is saying the disturbance wave is traveling, but disturbance wave on water surface is not traveling upstream. So if it is not traveling upstream, that does not mean that it is not traveling at all. This means that it is traveling towards the downstream side. Okay, so now what is the flow? You have to give the answer. So I'm creating the poll. You have 60 seconds and or 90 seconds I will give. Please understand. If you are not able to understand, you can make the diagram. After making the diagram, you can give me the answer. As previous year questions of OCF are very less, so we will be solving all the PYQs because previous year questions are only 20-25 questions. So we will be solving all the PYQs today. Okay, and if some questions are remaining, so we will solve those questions in the next session. Next session is at 7 p.m. in different channel, that is your GATE wala MECE. So first please solve this, then we will discuss the remaining things. Okay, so let's make the diagram first. So this is your river bottom, and the flow is happening over it. The flow is happening over it like this. This is the level. So what happens at this section? Suppose at this section we are dropping a stone, or we are throwing a stone here. Here we are throwing a stone. So what happens? This is the upstream section. Upstream means opposite to flow. This is the downstream section, and the flow direction is this. Okay. So what will happen? This stone will try to create a wave of celerity c. This will try to create the wave of celerity c. This will try to create a wave of celerity c. Celerity c. If v is greater than c, so what will happen? The resulting wave will travel downstream side. The resulting wave will travel downstream side if v is greater than c, and vw will be equal to c minus v, that is negative. And negative means the wave will travel downstream side, and this is only happening when v is greater than c, means v by c greater than 1, and this is also Froude number. And this means that the flow is supercritical. So you can make the diagram also. When the v is more than the celerity velocity c, velocity of celerity c, then the wave will travel, but it will not travel upstream. It will not travel upstream means it is traveling downstream. If it is saying the wave is not traveling at all, then the flow is critical. But if it is saying that the wave is not traveling upstream, means wave is traveling, but it is not traveling upstream, it is traveling downstream. And also here there is no option of critical. So we cannot say that the wave is not traveling at all, because there is no option of critical flow. So the answer will be B part, supercritical. Okay, B part is the correct answer. So everybody has given the correct answer. So start is very good for you. This question was asked in GATE 2008 for 1 mark. You know this thing. Now next question is in GATE 2008 again, and it is of 2 marks. So the question is asking that water emerges from an Ōgi spillway with velocity 13.72 meter per second and depth 0.3 meter at its toe. The tailwater depth required to form hydraulic jump at the toe is. So they have given you the value of y1, that is 0.3 meter. And they have also given you the value of v1, 13.72. Using these two things, you can calculate the Froude number f1. You can calculate the Froude number f1. And when you have got the Froude number f1, from this formula, y2 by y1 is equal to 1 by 2 minus 1 plus under root 1 plus 8 f1 square. You can calculate the y2 value. So use this y1 and v1 to calculate f1, and when you will calculate f1, you will get the y2 value. So this is the method to solve this question. This was for 2 marks. So definitely you will need 120 seconds, because first Froude number you have to calculate, then you have to apply in this formula. So I have given you 2 minutes. Solve this question and give me the answer. And if anybody is having solutions of previous year question in front of him, then believe me, you are doing the betrayal with yourself, not with to any other. You are doing the betrayal to yourself, because you will give the answer, you will give the option, but that will not benefit you in the exam. So if you are having answer key in front of you, there is no use of it, because we are going to learn a lot of things here. So please solve the question without answer key, without putting answer key in front of you, because this is your live practice of PYQs. If somebody has not done practice of PYQs, he can do here. That is why we have started this session. Okay, your time is over. Let us see what is the solution. So here if we will calculate the value of F1, so F1 will be equal to V1 divided by root GD. Okay, what is the D for rectangular section? The hydraulic depth for rectangular section is A by T. The area is B into depth of flow Y1 and top width is also B for rectangular section. So it is Y1. So we can directly write down Y1 here. So hydraulic depth for rectangular section is also equal to depth of flow Y1. So here we will get the Froudy's number 13.72 upon under root G. What we have to take here is not, here G is not given, so we will take 9.81. Sometimes the G is given as 10 or sometimes given as 9.81. But here if nothing is given, you have to always take 9.81 into 0.3. So we will get the Froude number here. So F1 we will get first here. This is 8. So if F1 is 8, we will calculate the value here. So 1 by 2 minus 1 plus under root 1 plus 8 into 8 square. So generally when Froude number is between 4.5 to 9, generally when the Froude number is 4.5 to 9, the flow is called as, the hydraulic jump is called as steady jump. And the depth of jump after the jump is generally 6 to 12 times. So here about it will be in the range 6 to 12 times. 9 to 10 times I think you will get. So let us check what we are getting. .8 times we are getting. .247 meter. The nearest option is C part. We are getting 3.27 means 10.8 times. So this C part is the correct answer. All of the students have given the correct answer. Very good. So you can see in 2008 exams or 2009 exams, previously 10 to 15 years ago, they are asking very easy questions. But latest, when we will come to the latest questions now, when we will come to the questions after 2020 or 2019 after COVID, so we will see that they are asking very difficult questions. So the competition has been high because that is why the question is also very difficult. So continuously we are having 3 questions now. Now continuously we are having 3 questions. The question number we can say 3, 4 and 5. We can say like this. Question number 3, 4 and 5. So question number 3, 4 and 5. 40, 41, 42 was in our book. That is why it was written. So question number 3, 4 and 5. For the next 3 questions, this was question number 1. This was 2. This was 2. This was 1. So 1, 2, 3, 4, 5. Okay, a rectangular channel of B 6 meter. 6 meter wide means B is equal to 6 meter given. Then it carries a discharge of 16 meter cube per second. Meter cube per second means capital Q is given. If a small q is there, then it will be given as meter cube per second per meter or meter square per second. Okay, so it is meter cube per second means capital Q. Uniform flow is there, and normal depth of the flow is 1.6 meter. This is yn or y, you can say yn or y. It is 1.6 meter. Okay, because in GVF we generally say uniform flow as yn. In GVF we say y as GVF flow depth and yn as uniform flow depth. Manning's n is 0.015. So n is 0.015. These things are given. So what they are asking, let's see. 3 questions are there. So this is the data given. So write down this data because I will be coming to the next page. So please write down this data because this is important to solve the question. Write down this data first. Then we are going to move ahead. Okay, now the first question means question number 3 they have asked the longitudinal slope of the channel is, means SB they are asking. What is the value of SB they are asking? So you can apply the Manning's equation. You can apply the Manning's equation to calculate the SB value. Okay, so I am creating the pole. I am creating the pole for this. Okay, then I will tell you very interesting thing. I am not concerned about the answer because everybody has answer key with him. So some students, what they will do? They will simply see the answer key. They will give the answer in the comment box, but they don't know that just giving the answer is not clearing your exam. You have to solve this by your own without observing the answer key. So if you are doing betrayal, so you are doing betrayal actually with you, none other than you. You are the only person who is getting betrayed if you are giving the answer just only seeing the answer key. So I will be giving you some additional things here. That is the main purpose of this session. So solve this question quickly, then we are going to move towards the next question. So we have 25 questions today, or more than 25. So I will be going fast. Okay? Because we have a lot of questions today. Yes, we have a lot of questions today. So if some questions we are not able to solve right now, we will be solving the remaining questions in the next session, that is 7 p.m. at 𝐁𝐚𝐴 𝐶EXE. So if somebody is not getting all the question, you can join that 7 p.m. session. So how to solve this? Just we have to apply the Manning's formula. Q is equal to 1 by n into A into R raised to power 2 by 3 into SB raised to power 1 by 2. Now let's calculate all the things. Q and n are given. A is equal to B into Y. A is also given. B into Y. B is I think 6 and Y is 1.6. Am I right? Yes. So it will be 9.6 meter square. Let's calculate P. Perimeter is B plus 2Y. It is 6 plus 2 into 1.6. This will be 9.2 meter. So what is the value of R? Or R is A by P. So here we will write down from this equation. From this equation we will write down 16 is equal to 1 upon 0.015. Is it correct? 16 is the Q and is 0.015. Yes. Into area. Area is 9.6 into A by P, 9.6 upon 9.2. Raised to power 2 by 3 into SB raised to power 1 by 2. When you will calculate SB from here, you will get 0.000585. 0.000585. I will check. I have checked this. I have checked this in my calculator. But I will check you in front of you also. I will check this in front of you also. Yes, 0.000585. It is absolutely correct. So this A part is the correct answer. So here we have got A part as the correct answer. As I know, answer will be correct for everyone. Just you have to do the practice here. Now it is asking that a hump is to be provided on the channel bed, the maximum height of hump without affecting the upstream flow condition. I have told you that the maximum height of hump, the formula in the last class I have also given you. Whenever you have to calculate delta Z max, it is equal to E1 minus E minimum, because at section 2 the specific energy will be minimum. When at section 2 the specific energy is reduced and it is getting minimum. So that is the maximum height of hump. Maximum height of hump is that height where at section 2 the specific energy E2 is equal to E minimum. At this time we will call this delta Z as delta Z max. So if we are making the hump very high now, so at section 2 what will happen? This is E1. At section 2 when we are making very height of hump, very much height of hump, so this E2 will become E minimum. This is called delta Z max, maximum height of hump. Okay, so you know this thing. You know this thing. We are not going to make the diagram in the exam. We have to just apply the equation in the exam. So the equation is important here. In solving the questions, diagrams are not important. Diagrams are important only in understanding the theory part. Here you can directly solve by this equation. Okay, and for B minimum, what we have to do for B minimum? For B minimum, you have to take E1 is equal to E2, both has E minimum. Both are minimum whenever B minimum is there. Okay, So I am creating the poll for this. Again giving you 150 seconds because this will take time. You have to calculate a specific energy at both sections. So give me the answer. Quickly give me the answer, then we will move further. Okay guys, let's see the solution. So what is E1? E1 is the specific energy at section 1, that is Y1 plus V1 square divided by 2G. Or we can write it down as Y1 plus Q square divided by 2G A1 square. Why A1 square? Because velocity is discharged by area. So here we will calculate E1. E1 is equal to Y1, that is I think 1.6 plus Q square is 16 square upon 2 into 9.881. Area we have calculated as 9.6. So this was the flow coming from the upstream side. ये हमारा flow, this flow was coming from the upstream side. ये flow आ रहा है upstream side से, and it is going towards the downstream side. So 16 square divided by 2 into 9.81 into 9.6 square plus 1.6. This is 1.7416. 1.7416 meter. If I'm not wrong, let me again calculate. Yes, 1.74. Okay. Now at the section 2, the specific energy is minimum. So E2 we know that what is the minimum specific energy? The minimum specific energy is 1.5 or 3 by 2 of YC. So 3 by 2 of YC. What is YC? YC is Q square divided by G raised to power 1 by 3. So this is 1.5. What is Q square? Q is discharge per meter width. Discharge upon width 16 by 6 whole square upon G 9.81 whole power 1 by 3. This whole power 1 by 3. This is the minimum specific energy. Let's check what is the value coming out to be. This is 1.34 75 meter. So what is delta Z? Now we can calculate the delta Z is equal to, from here we can calculate the value of delta Z. Delta Z here equal to E1, that is 1.7416, minus E2, that is 1.73475. So here we will get the value of delta Z. .394. So nearly 0.4 is the correct answer. Nearly 0.4 is the correct answer. Okay. So B part is the correct answer. So everybody is giving the correct answer. So Vinay, Ritika, Vikas are top 3, then Yusuf, Suraj are 4 to 5. Overall 19 students are giving answer till now. Now let's move to the next question. Next question is question number 4. Again, I think this is again, sorry, this was 4. Next is question number 5. Again, the same question is from GATE 2008. The same question is from the same data. Now it is saying the channel width is to be contracted. When the channel width is to be contracted, you have to do B minimum. You have to make B2 as B minimum. Channel width to be contracted means B2 you have to do less than B1. The minimum width to which the channel can be contracted without affecting the upstream flow. Minimum width means B2 will be lesser than B1. With contraction means B2 will be lesser than B1, and minimum width means whatever is B2, that is the minimum value. You cannot reduce the B2 value beyond this B minimum. So width contraction means the second width, the downstream side width is lesser than B1. This is width contraction, and minimum is B2 is equal to B minimum. These two are having different meanings. Okay, but connectively we can say that we are reducing the depth to minimum value, and upstream flow we are not obstructing, only downstream flow we are obstructing. So whenever the downstream flow is affected, the B minimum will be equal to, I think this is calculating now, B minimum you need to know. So at B minimum, Q2 will become Q maximum. And what is Q maximum? Q maximum will be equal to Q upon B minimum. Q2 will become Q maximum, that is Q upon B minimum. That will happen when minimum width we are providing. And you know, even whatever even you have calculated, that will be becoming equal to E minimum. Even will also become to E minimum. Even will also become, or we can say even will become E2, and this E2 value will become equal to E minimum. Okay, even will become y1 plus v1 square by 2g. E2 will become E minimum. Whenever we will calculate both these things, what we will do, we will equate these two things. E1 will be equal to V2. Because in width contraction, the specific energy is not reduced. In width contraction, what happens? In width contraction, generally the discharge is changed. Discharge per meter width is changed. Okay. So E1 we have already calculated. I think in the previous question we have calculated 1.7416. So the upstream flow conditions are not affecting, without affecting upstream flow conditions. So E1 will not change. E1 will be same. But E2 will become now how much? 1.5 or 3 by 2. This Q max is square by G raised to power 1 by 3. E2 will become now in the terms of Q max. So E2 you will write down E minimum, that is, I will write down here, that is 1.5 YC. YC will be Q max square by G raised to power 1 by 3. So calculate first Q max from this equation and put Q max is equal to Q by B minimum. So you will get the B minimum value. Okay, E1 will be unchanged because it is saying without affecting upstream flow condition. So E1 will be same that we have calculated previously. To solve this quickly, I am giving you the time. So within half an hour, we have solved 5 questions. So that is why I am saying now we will be solving 25 questions today. So 25 we will be solving, and if some questions are remaining, we will be solving in the next session, that is at 7 PM, but at different platform, at GATE wala MECEXE. Everybody is saying 4.1c. So let's calculate. So even we know that E1 is equal to same 1.7416. So that would be same 1.7416 equal to E2. E2 will be equal to 1.5 into Qmax square divided by 9.81 raised to the power 1 by 3. So here we will calculate Qmax. What is the value Qmax is coming out to be? Let us check. What is the value Qmax is coming out to be? $3.9185 is equal to Q upon B minimum. Q is 16. So here B minimum will be equal to how much? 16 upon this value. So it is coming out to be 4.083 meter. This is the minimum width. So 4.083 means 4.1 we can give the answer, C part. 4.1 we can give the correct answer. So C part is the correct answer. Okay, everybody has given the correct answer. I know that this thing is clear to you. Next question, question number 6 we are going to solve. Direct step method of computation of the gradually varied flow is. Direct step method we are doing for which type of channels? This is applicable. In the first line it is A9 na, this is not A9, this is actually applicable. You understand this thing very clearly that this will be applicable. Applicable to non-prismatic, applicable to prismatic, applicable to both prismatic and non-prismatic, not applicable to both prismatic and non-prismatic. So I am creating the poll, but here I will give you only 90 seconds because this is of 1 mark only. This is of 1 mark only. So in gradually varied flow, what we are applying the formula, dy by dx formula, that is which type of method? That is that we are applying the dy by dx is equal to how much? So I have told you that this is only for which type of channel? Rectangular channel. I have told you there. So this is only for a rectangular channel. So rectangular channel will be generally prismatic. Generally prismatic, not always, but generally prismatic. I have told you this thing in the last class. So exactly whatever I have written in the slide now, every year these slides, these theory slides, I am teaching from the last 15 to 16 years or at least 12 to 13 years. So I have made these slides when I was studying the open channel flow during my preparation in 2008 or 9, because in the year of 2009 I have started my BTech, and I was continuously making the notes. So those notes, whatever I'm making, those notes are from that time, and I'm continuously updating that notes. So whatever I'm updating that notes every year, every next year, 2013, 2014, 2016, the questions have come from that notes, because whenever you are updating your notes continuously now, so at one time after 3 to 4 years, so notes will be like that everything is included there. That is why each and every thing, whatever you will learn or whatever you will see in the exam, every question you will see that there is something for in the notes. So this is B part. Okay, now let's move to the next question, question number 7. Question number 7. So previously B part was the answer. Let us give me the answer. Okay, everybody has given the answer. Now I'm creating the poll for this question. Again, this question is of 2 marks, so I'm giving you 150 seconds for this. Give me the answer. There are 4 options. A rectangular open channel of width 4.5 meter is carrying a discharge of 100 meter cube per second. Okay, the critical depth of the channel is, this is very simple. Discharge is given, width is given, calculate small q, and for rectangular channel, what is the critical depth? Q square by g raised to power 1 by 3. That is very simple. So I don't think that you need 150 seconds. I think you will be solving within 90 seconds or 100 seconds. Solve this, give me the answer. In the back end, I am also calculating that what will be the answer. So how to solve this? The time is going to be over. I will end the poll before ending of the time. I will end the poll because this is a very simple question. So here YC for rectangular channel we will be having Q square by G raised to the power 1 by 3. But this is only applicable for rectangular channels. This is only applicable for rectangular channels, not for any other channel. For other channels, you have to calculate the form by formula Q square T by GA cube is equal to 1 or FR is equal to 1. So what is Q value? Q is equal to 100 upon 4.5. So that is 22.22 meter cube per second per meter. So when you will calculate YC will be equal to 22.22 upon G is 9.81 whole square raised to power 1 by 3. So you will get, what you will get? I am stopping the poll. So you will get answer as B part 3.9. Absolutely correct. So B part 3.9. When you will calculate this now, you will get this thing 3.9. Okay. Let me check once again. I think I'm right. I think I'm right. I will not be wrong because I have calculated this before. Yes, 3.69. 3.69. B part is the correct answer. Okay. Okay. So let's see the leaderboard. Vinay, Ritika, Yusuf, Swagatam and Akansha, they are top 5 and overall 26 students are giving the answer till now. Now let's move to the next question. This is the question number 8 now. A mild sloped channel is followed by a steep slope channel. This is the question of your flow profiles. Okay, region of flows. Slope channel, the profile of gradually where it flow in the channel are. So what is the mild slope? Let us make the mild slope. Mild slope has bed slope very smaller than the critical slope, and then it is followed by the steep slope. So steep slope has the slope larger. So this is a steep slope SB2. This is having the slope value greater than critical slope, and this is the value of mild slope SB1. This is having slope lesser than critical slope. So here there is a break in grade where at this point here this is the break in grade. This is called break in grade, also known as control section, because in control section we can make each and everything. And this is your critical depth line. Critical depth line means critical flow. If critical flow is occurring, then it will occur here. The another line is normal depth line. Normal depth of flow in mild channel happens above CDL, above critical depth. When in steep channel, it happens below CDL. So this is your NDL, normal depth line, means YN level. So this is NDL 1. This is NDL 2. This is your CDL. This is your CDL for mild slope. This is your CDL. CDL is same for every slope. CDL is not different for different slopes. So this is your mild slope. Mild means M. The bed slope is lesser than critical. This is your steep slope. Steep slope means S, more than critical. The profile will be either M, either S, or M, combination of M and S. Either M or S or the combination of both. Okay. So I'm creating the poll now. I will be giving you 90 seconds because this is a very easy question. So A, B, C, D, whatever is the answer, you can give me the answer. I have made the diagram also so that you will be comfortable to give the answers. I have made the diagram so that you will be comfortable to give the answer. So let's make the regions first. This is the region 1, this is the region 2, this is the region 3. Again, we are making the regions here. Here again we are making the region. This is the region 1, this is the region 2, this is the region 3. Top line above region 1, top line to bottom line region 2, bottom line to bed region 3. Similarly here. Okay. So flow will be happening in which region? Where it is meeting NDL to NDL. Wherever it is meeting NDL to NDL, that will be your flow. Okay. So now here the flow is coming from NDL because previously the flow was normal flow, uniform flow. Here it will also go to the NDL. So the flow will start here and it will meet here. Okay. Every time from the long prismatic channel, when this channel is long, it will be uniform. And previously this channel was long, it will be again uniform. So it is coming uniform flow and it will meet in the uniform flow. In this range, wherever disturbance is there, here the profile will be made. So here it will, this NDL is trying to meet this NDL, so it will drop first. It will drop like this. Let us make this profile somewhat ahead. So here it will come from NDL and it will first drop like this. Okay, meeting the CDL almost at 90 degree, and again it will be coming out of CDL at 90 degree and it will meet here like this. So this profile will be made like this. So here in mild slope it is moving in region 2. So here it is M2 profile, and here in this slope it is also moving in region 2. So it is also S2 profile. So the answer will be M2S2. So M2S2 is given in D part. So the answer of this question will be M2S2. Every time remember, the profile always try to meet from NDL to NDL. So you have to just meet from NDL to NDL. Where the flow is moving, the flow will be called as, the range will be called as flow profile. So here it is moving in M2, here it is moving in S2, so M2S2. D part is the correct answer. Very less number of students, only 14% students are giving the answer. I have given the correct answer. Vinay, Swagatam, Ritika, Nitin, Yusuf, top 5. Overall 27 students are giving the answer. So please always remember, you have to meet NDL to NDL. Whatever is you are observing, that will be profile. Don't consider profile by yourself. Every time whenever I am teaching profile, I always say that don't assume the profile by yourself. Just meet NDL to NDL. Whatever is coming, that will be your answer. Don't assume the profile by yourself. What students do, students always do mistake in the profiles when they are assuming the profiles like this. If you are not making the diagrams in flow profiles, 90% chance are there you will be doing mistakes. If you are not making the profile. In previous questions, I have not made the diagram. Here I have not made the diagram. Even in the hump question, in the width contraction, I have not made the diagram, because here there is no confusion. If you will not make the diagram, you will not do the wrong things. But in flow profile, whenever break in grade is there, whenever you are making the flow profiles, now always make the diagram. Because here if you have not made the diagram, now you will definitely do the mistake. Okay, so don't give the random answer whenever a flow profile question is there. Always make the diagrams. Because what happens here, this is region 1, and now you will think that it is coming to region 1 in S1. From region 2 it is coming to region 1. This is region 1. So you will think that this will be S1. No, it is not coming in region 1. It is coming in region 2. And that will be confirmed only when you will make the diagrams. So multiple times I have told, in flow profiles, make the diagrams. Okay, so last was your question number 8. Now we are coming to the question number 9. 1 hour 10 questions. So I am sure that in 3 hours we will be reaching 25, more than 25 questions or 25. Okay, so let's create the poll for this question. 1 mark question. I am giving you 90 seconds. Poll is started. The flow in a rectangular channel is subcritical if the width of the channel is reduced at a certain section. The water surface under the no choke condition will be. No choke condition means if you are contracting the width below B minimum, if you are contracting the width lesser than B minimum, then the flow is choked, or you are making hump more than delta Z max. If somebody has made the hump higher than delta Z max, then the choke condition comes. So no choke condition means width is minimum to minimum, it is coming to B minimum. That is the critical value. So that critical value, when the width is reduced up to the minimum value, what happens? That is asking. Okay, always remember the depth of flow, try to go towards the critical value. Whenever you are making the hump or you are making the width contraction, always the flow tries to go towards the critical value. If you have done the opposite thing, then the opposite will happen. If you have reduced the bottom, or if you have increased the width, then reverse will happen. But always in hump creation and width contraction, the flow depth will try to move towards the critical value. Okay, sometimes it moves to critical value, sometimes it does not move to critical value, but it tries to move towards the critical thing. Okay, so which type of flow? Subcritical flow. In subcritical flow, what happens? Subcritical flow, the depth of flow is more than the critical value. In subcritical flow, the depth of flow is more than the critical value. Okay, so what will happen if you are reducing the width or making the hump, anything you are doing, reducing the width or making the hump, it will try to go towards the critical. So how it will go towards the critical? It will reduce. So it will drop at the downstream section. It will drop at the downstream section. Always the downstream section is affected. Upstream is not affected. Always the downstream section is affected. So in a rectangular channel, if the width of the channel is reduced, so the water surface will reduce or drop at the downstream section. It is simple. Always the depth of the flow tries to go towards the critical value. Always remember one thing, otherwise you will be confused. Only one concept is that whenever you are making the hump or you are reducing the width, in both conditions the flow depth tries to go towards the critical. So in subcritical the depth of flow is more than critical, so it will be reduced, it will try to go towards the critical. That is why when B minimum is there, at the downstream section the flow is critical. That is why, because at B minimum it goes to critical value, it reduces to critical value, and in supercritical it is increased. So always remember the depth of flow tries to go towards the critical value. In the last class I have also told, if you are making hump or width contraction, both should be smooth. Okay, both should be smooth, both things should be smooth, not sudden. Smooth hump creation or smooth width contraction, smooth. So what will happen, yn will try to go towards the yc. If your hump is maximum, delta z max, so at downstream section the flow is critical, and if width is minimum, if delta z is max, at downstream section the flow will be critical, and if width is minimum, at downstream side the flow will be critical. So always the subcritical flow will reduce and supercritical flow will increase, because it is trying to go towards the critical. It is very simple, drop at the downstream section. A part is the correct answer. Okay, upstream section is not affected. अपस्ट्रीम में राइज कैसे होगा, नो चोक कंडीशन लिखी हुई है. Here it is written no choke condition is there. So in no choke condition upstream section is not affected. When the flow chokes at downstream, then the flow reverses. So if you are doing B lesser than B minimum, the B2, if B2 is, you are doing B2 lesser than B minimum, then upstream section will be affected, because then choking will come. And or you are making delta Z more than delta Z max, then choking will come. Then the flow will be choked at downstream side, the flow will be reversed, then upstream will be affected. Here clearly written no choke condition. Getting my point? And I have also taught this thing in your crash course. Yesterday I have given the revision also, and in crash course I have also taught that until and unless no choke condition, until and unless choke condition is reached, upstream section will not be affected. Only downstream will be affected. The flow will go, and whenever you are doing this, then this section will be affected. This will not be affected. This depth y1 will not be affected. But if here this height is very high, more than delta z max, this hump is very high, or width is very less, then it will be blocked and it will come back. Are you getting my point? Is it clear? समझ में आ गई बात? क्लियर? कितने साल की PYQ बुक लूं? 38, 25 और 8 साल. अरे भाई जितने साल तुम लगा सको, 10-15 दिन गेट एग्जाम के लिए बचे हैं, जितनी तुम लगा सको. 38 साल के लेके बैठे क्या करोगे? लगा पाओगे? और अभी खरीदोगे, पता नहीं कब तुम्हारे घर आएगी. ऑनलाइन लोगे तो और टाइम लगेगा, दुकान में जाके लोगे तो ले आओगे. जितना जल्दी खरीद सकते हो, जितना लगा सकते हो खरीद लो. तुम ये क्वेश्चन अभी क्यों पूछ रहे हो? 15 दिन बाद पूछ लेते, गेट एग्जाम के एक दिन पहले पूछ लेते कौन सी खरीदूं. 15 दिन में तुम क्या कर पाओगे? 38 साल लगा पाओगे? थोड़ा प्रैक्टिकल सोचा भी तो करो. पागल वागल होना है क्या हमें? सोचा तो करो क्या कर पाएंगे हम. कैसे लगा लोगे तुम 38 साल 15 दिनों में? और लगा लोगे तो पागल हो जाओ. गेट एग्जाम के दिन बोलोगे मैं पागल हूं, ऐसे बोल के एग्जाम देने जाओगे. प्रैक्टिकली सोचो ना थोड़ा. 38 साल कैसे लगा लोगे तुम 15 दिन में? ओके, सो ए पार्ट विल बी द करेक्ट आंसर. समझ में आ गई बात? तो वही हम लोग बोल रहे हैं कि प्रीवियस ईयर क्वेश्चन से हम लोग क्या सीखने वाले हैं. प्रीवियस ईयर क्वेश्चन से हम लोग सीखने क्या वाले हैं, वही चीजें हैं. चोक कंडीशन कब आएगी? जब आप डेल्टा जेड मैक्स से ऊपर हम्प बनाओगे, या फिर B2 को बी मिनिमम से कम करोगे, तब चोक कंडीशन आएगी, तब अपस्ट्रीम अफेक्टेड होगा. तब यही आंसर देना है कि अपस्ट्रीम अफेक्टेड होगा, चोक कंडीशन आ जाएगी. तब तो पढ़ा रखा है यार, तुम लोग पढ़ोगे कोर्स अच्छे से तो सब हो जाएगा. पढ़ोगे नहीं तो दिक्कत होगी. ये क्वेश्चन करिए, गेट 2010 में आया था 2 नंबर का. एक रेक्टेंगुलर चैनल है मैच लिस्ट 1 और ज्योमेट्रिक एलिमेंट्स दे रखे हैं उसके लिस्ट 2 में। प्रोपोर्शंस ऑफ द हाइड्रोलिक एफिशिएंट सेक्शन, मतलब हाइड्रोलिक एफिशिएंट सेक्शन के बारे में बता रखा है। तो लिस्ट 1 में ज्योमेट्रिक एलिमेंट्स दे रखे हैं, सॉरी लिस्ट 1 में एलिमेंट्स दे रखे हैं, लिस्ट 2 में उसके प्रोपोर्शन दे रखे हैं हाइड्रोलिक एफिशिएंट सेक्शन के लिए, है ना। अब आपको मैच करना है कोड्स गिवन बिलो, कोड्स यूज करके आपको मैच करना है कि क्या होगा। तो मैच करिए। आई एम क्रिएटिंग द पोल, रेक्टेंगुलर चैनल के लिए ध्यान रखना, है ना, रेक्टेंगुलर चैनल के लिए। ठीक है, मैच करिए। आई एम क्रिएटिंग द पोल। 2 नंबर का है, चलो मैं आपको 150 सेकंड दे देता हूं, हालांकि लगेगा नहीं 150 सेकंड। वाई क्या है? डेप्थ ऑफ फ्लो है, करस्पॉन्ड टू हाइड्रोलिक डिफिनेशन चैनल। वाई क्या है? डेप्थ ऑफ फ्लो, कम से कम 10,000 साल की। दस हजार साल में तो वो वाले क्वेश्चन भी होंगे ना जो स्टोन एज में आते थे, स्टोन एज में आते थे, जिसमें वो लोग ऐसे क्वेश्चन ऐसे लिख के पूछते होंगे, हाशा मुशी क्वेश्चन मुशा मुशा क्वेश्चन मुशा, ऐसे करके क्वेश्चन लिख के आते होंगे। या उस समय गेट रिटन नहीं होता होगा, वर्बल होता होगा 10,000 साल पहले। कैसी बातें करते हो यार। मतलब क्वेश्चन क्या आते होंगे 10,000 साल पहले? 10,000 साल पहले क्वेश्चन क्या आते होंगे कि शेर का शिकार करने और बाघ का शिकार करने में पत्थरों में अंतर बताओ, है, ऐसे क्वेश्चन आते होंगे। या किसकी किसकी खाल का स्वेटर पहनने से ज्यादा गर्मी मिलती है और ज्यादा ज्यादा जाड़े में जो है थर्मल ट्रांसफर कम होता है, कितना थर्मल एनर्जी स्टोर होती है, ऐसा। और किस भाषा में पूछते होंगे? ठंड भगाने के जो हमारे तरीके हैं ना, वो स्टोन वेज से अलग अलग चलते आ रहे हैं। उसके बारे में क्वेश्चन तो हर एग्जाम में आएगा ना, मैकेनिकल में तो आता ही होगा। तो वो बोल तो रहा है, राज बोल रहा है पहले कपड़े नहीं थे एग्जाम का देंगे, तो राज बोल तो रहा है भाई कि 10,000 साल पहले के पेपर उठाओ, तो वहां पे कौन से क्वेश्चन होंगे? यही होंगे, है ना। फिर हीटर का आविष्कार हुआ, फिर हीटर भी अलग, अब नए टाइप के हीटर चल रहे हैं, ऑयल फील्ड रेडिएटर वाले हीटर चल रहे हैं। इसमें क्या है भैया टेक्निक? भैया इसमें जो है ना, जो आपका हवा है उसका मॉइस्चर खत्म नहीं होगा। वाह भाई, यहाँ साला सांस जो है लेने के लिए अच्छी हवा नहीं है, तुम हवा के मॉइस्चर में भी लग रहे हो। हमने सुना था हमने सुना था कि हवा में जितना मॉइस्चर है, जितना वेपर है, वो ग्लोबल वार्मिंग कर रहा है, तुम उसको और बढ़ाए दो और उसको जो है कंट्रोल रख लो। वो खतरनाक लोग हैं, तरफ बोलेंगे कि वेपर जो है ग्लोबल वार्मिंग कर रही है, फिर बोलेंगे कि भैया इसमें इसमें मॉइस्चर खत्म नहीं होता। भाई बात सही है, बिल्कुल सही बात है, मजाक अपनी तरफ है कि भाई मॉइस्चर खत्म नहीं होगा तो आपका बॉडी ड्राई नहीं होगी, बट मतलब खतरनाक टेक्निक चलती है। पहले पुराने जमाने में बोलते थे कि भैया ये जो मिट्टी का लेप है इसको मत लगाओ, मिट्टी का लेप है इसको मत लगाओ, फेस वॉश लगाओ, बढ़िया एकदम त्वचा एकदम गोरी हो जाएगी। फिर फेस वॉश में भी कार्बन डालने लगे, कार्बन लगाओ। फिर फेस वॉश में मुल्तानी मिट्टी ऐड करने लगे, फेस वॉश में मुल्तानी मिट्टी ऐड करने लगे। फिर पता नहीं, फिर नए नए लोग आने लगे, मौसी अर्थ, चाचा ब्रह्मांड, ऐसे करके फेस वॉश लेके आने लगे। और उसमें तो भैया कुछ है ही नहीं, मिट्टी ही है सिर्फ। पता नहीं स्टोन एज से हम वापस स्टोन एज में चले आ रहे हैं। चलो अब इसका आंसर देखते हैं, फालतू बातें बाद में क्लास के एंड में करेंगे, है ना। आगे बढ़ते हैं। ये देखो, एक ऐसे ऐसे लोग चले आते हैं, नाम कुछ नहीं समझ में आया तो एनएसजी रख लिया सीधे। उधर जाओ बेटा, गेट में भी यही फॉर्म भरे होगा, गेट में भी यही फॉर्म भरे हो क्या? इस साल इडली चटनी नो सांभर आया था एडमिट कार्ड, अगले साल आएगा एनएसजी लेजियन मास्टर योर एडमिट कार्ड फॉर मास्टर। एडमिट कार्ड आएगा नहीं इनका सीधे मास्टर ऑफ टेक्नोलॉजी आएगा, क्योंकि मास्टर तो कर ही चुके हैं। योर एमटेक डिग्री इज हियर। गेट का फॉर्म भरेंगे सीधे एमटेक डिग्री हिसाब। मास्टर तो नाम में ही है ना, पहले ही लगा लिए गेट फॉर्म भरने के। तो टॉप विड्थ कितनी होती है? टॉप विड्थ होती है 2 × y, तो 2y ही कर दो। पेरीमीटर कितनी होती है? b + 2y, तो b + 2y क्या b2y होता ही है, तो फिर ये हो जाएगी 4y। इतना आसान है यार, 3 और 4 तो यही हो गया। और खतरनाक खतरनाक के लोग होते हैं। अभी मैं क्लास जो है, अभी क्लास खत्म करूंगा, क्लास खत्म करने के बाद, अभी क्लास खत्म करने के बाद पता है कुछ बच्चे पूछेंगे सर ये 2y से 3y कैसे हो गया। ऐसे भी खतरनाक लोग हैं, मुझे पर्सनल मैसेज करते हैं, दिमाग खराब करते हैं, सर ये 4y का 4 है यहाँ पे 2y 3 कैसे हो गया। मतलब खतरनाक लोग हैं। हाइड्रोलिक रेडियस कितनी होती है? हाइड्रोलिक रेडियस होती है आपकी y/2। y/2 कहां दे रखा है? 1 में, तो 1 से मैच करेगा। और हाइड्रोलिक डेप्थ क्या है? हाइड्रोलिक डेप्थ आपकी ye के बराबर ही होती है, तो किससे मैच करेगा? 2 से। सो 3 4 1 2, 3 4 1 2 कहां दे रखा है? सी पार्ट में। और तुमको मजाक लग रहा होगा कि सर ये मजाक कर रहा है, मैं तुमको यार अब किसी बंदे का जो है वो क्या बोलते हैं मान हानि की वाली बात आ जाएगी, वरना बता दिखा देता तुम लोगों को ग्रुप में। ऐसे ऐसे भी लोग हैं, सर ये 2y से 3 कैसे हो गया, यहाँ तो 4 का 4 ही है, यहाँ 1/2 का 1, यहाँ 2 का 3 कैसे हो गया, ये 1 का 2 कैसे हो गया, 1 2 का 4 कैसे कर रहे हो आप। ऐसे ऐसे खतरनाक लोग हैं, क्या बताएं, मतलब दुनिया में ऐसे ऐसे लोग भरे पड़े हैं। ये एनएसजी लेजेंड मास्टर को ब्लॉक कर दिया जाए जरा, बैकएंड पे जो भी हैं उनको जरा ब्लॉक करो। ये भाई लैंग्वेज, भाई साहब लैंग्वेज सही रखिए क्लास में, लैंग्वेज सही रखिए। लैंग्वेज सीधे सही रखिए बस क्लास में। ठीक है, इनको ब्लॉक करिए वरना मुझे फिर फोन करके बोलना पड़ेगा। सही नाम से आइए क्लास में, नहीं बोलेंगे हम, कुछ भी नाम लिख के आते हैं, फिर उसके बाद धीरे धीरे करके दूसरों को ही परेशान करते हैं। तो इतने लोगों ने सही आंसर दे दिया, आगे बढ़ते हैं। विनय, स्वागतम, रितिका, यूसुफ से लेके 30 स्टूडेंट आंसर दे रहे हैं। मैं क्लास में कितना भी मजा कर रहा हूँ, लैंग्वेज मेरी बहुत बैलेंस रहती है। तुम लोग स्टूडेंट होके खलीफा बन रहे हो। नेक्स्ट, द फ्राउड नंबर ऑफ फ्लो इन अ रेक्टेंगुलर चैनल इज 0.8। ठीक है, इफ द डेप्थ ऑफ फ्लो इज 1.5 द क्रिटिकल डेप्थ इज। तो ये बहुत सिंपल कॉन्सेप्ट है ना। इज इट क्लियर? समझ में आ गया? इसको सिंपल सॉल्व करिए। तो नंबर कहां से मिलेगा बेटा? हमको नंबर नहीं मिलेगा बेटा, हम तुमको अभी बस ब्लॉक ही करवा देंगे। और तुमको हम क्यों फोन करेंगे? इतना अभी बड़े नहीं होगा कि तुमको फोन कर दें। अभी इतना बड़े होने के लिए बहुत तुमको एग्जाम निकालना बाकी है कि तुमको कोई टीचर फोन करे, है ना। पहले एग्जाम निकालो, फिर मानो कि तुम्हारा नंबर। अजीब बात कर रहे हो यार, तुम्हारा नंबर लेने क्या करेंगे? हम अपने बीएम को, बैच मैनेजर को फोन करेंगे, बोलेंगे भाई हटाओ ये सब जो परेशान कर रहे हैं क्लास में। अभी बेटा पहले एग्जाम निकालो, फिर फोन भी करेंगे, हम भी करेंगे, हमारी कंपनी वाले भी फोन करेंगे, सब तुम्हारे पीछे पड़ेंगे, लेकिन एग्जाम नहीं निकालोगे तुमको कोई फोन नहीं करेगा। तो पहले अपनी वैल्यू बनाओ, ऐसा नहीं है। मतलब मस्त कंटेंट दे के चले जाते हो तुम लोग क्लास में, क्लास का माहौल बना रहता है। हमें लगता है 3 घंटे क्लास यार बोरिंग हो जाएगी, सिर्फ पढ़ाना है सिर्फ पढ़ाना। अभी देखो कितना स्पीड से पढ़ा रहा था मैं। तुम लोग आते हो बीच में कंटेंट देते हो, थोड़ा सा फिर से फ्रेशनेस आ जाती है। तो 11वां नंबर क्वेश्चन था आपका, है ना। इसके पहले आपका क्वेश्चन नंबर 10 था। चलो आगे करते हैं, कैलकुलेट। क्राउड नंबर कितना दे रखा है? 0.8 और डेप्थ ऑफ फ्लो दे रखी है 1.5। अच्छा ये सब दे क्यों रखा है? क्योंकि देखो क्रिटिकल डेप्थ निकालने के लिए आपको क्यू चाहिए, और क्यू कैसे मिलेगा? क्यू डिस्चार्ज कैसे मिलेगा? आपको कोई डेटा देना चाहिए, तो उसी लिए डिस्चार्ज निकालने के लिए डेटा दे रखा है। तो फ्राउड नंबर अगर आपको याद हो तो या तो हम v डिवाइड बाई रूट जी वाई लिख सकते हैं रेक्टेंगुलर चैनल के लिए, ठीक है, जिसके लिए d इज इक्वल टू वाई है। सबके लिए नहीं लिख सकते है ना। ट्रायंगुलर चैनल के लिए नहीं लिख सकते हम v डिवाइड बाई रूट जी वाई। ट्रायंगुलर चैनल के लिए d निकालना पड़ेगा, y/2 आता है d। तो ट्रायंगुलर के लिए फ्राउड नंबर होता है v डिवाइड बाई रूट जी वाई बाई 2। कुछ लोगों के लिए नया होगा ये, v डिवाइड बाई रूट जी वाई सिर्फ रेक्टेंगल के लिए, ट्रायंगल के v डिवाइड बाई रूट जी वाई बाई 2। ट्रेपेजॉइड के लिए अलग d निकालना पड़ता है। सिर्फ रेक्टेंगल के लिए लिख सकते हैं, इसको हम ऐसे भी लिख सकते हैं Q डिवाइड बाई अंडर रूट GY3। ये मैंने आपको हाइड्रोलिक जंप के समय बताया था। यहां से आप Q निकालोगे, कितना आएगा 0.8 इंटू अंडर रूट 9.81 इंटू YQ, Y कितना था 1.5 का क्यूब इज इक्वल टू Q। यहां से Q आ जाएगा, ठीक है, GY3/r से मल्टीप्लाई कर दिया, Q मिल जाएगा, तब आपको YC भी मिल जाएगा। तो नॉर्मल जब फ्लो हो रहा था, नॉर्मल यूनिफॉर्म फ्लो, तो 1.5 मीटर डेप्थ ऑफ फ्लो थी और 0.8 फ्राउड नंबर था, मतलब नॉर्मल फ्लो आपका सब क्रिटिकल था। अब ये पूछ रहा है कि जब क्रिटिकल फ्लो होगा, इसमें क्वेश्चन समझ रहे हैं, जब इसमें क्रिटिकल फ्लो होगा तो डेप्थ ऑफ फ्लो क्या होगी। 4.6 मीटर क्यूब पर सेकेंड पर मीटर। तो YC कितना हो जाएगा, YC हो जाएगा 1.5 इंटू 4.6 रेज टू द पावर 3 अपॉन स्क्वायर अपॉन 9.81 रेज टू पावर 1/3। यहां से आपको YC मिल जाएगा। वन 1.29 आ रहा है। ओके, यहाँ 1.5 नहीं होगा, वो आपका EC में होता है, क्रिटिकल एनर्जी में सिर्फ 1.292 आएगा। तो डी पार्ट इज द करेक्ट आंसर। ठीक है, आंसर तो सभी लोग ही सही देंगे। अगला क्वेश्चन, क्वेश्चन नंबर 12। फॉर अ गिवन डिस्चार्ज द क्रिटिकल फ्लो डेप्थ इन एन ओपन चैनल फ्लो डिपेंड्स अपॉन। किसी गिवन डिस्चार्ज के लिए क्रिटिकल डेप्थ ऑफ फ्लो किस पे डिपेंड करती है। बहुत अच्छा क्वेश्चन है, बहुत अच्छा क्वेश्चन है। ठीक है, इसको करते हैं। पोल मैं क्रिएट कर रहा हूं, इसमें आपको दूंगा 90 सेकंड का टाइम। 90 सेकंड सफिशिएंट है क्योंकि थ्योरेटिकल क्वेश्चन है, जल्दी से आपको आंसर देना है, क्विकली क्विकली आंसर देना है। देखो यहां पे कहीं रेक्टेंगुलर सेक्शन नहीं लिख रहा, रेक्टेंगुलर सेक्शन नहीं लिख रहा तो हम डिस्चार्ज कैसे निकालेंगे, Q² T/GA³ इज इक्वल टू 1 करके क्रिटिकल डेप्थ निकालेंगे, सॉरी, है ना, और फ्राउड नंबर इज इक्वल टू 1। अब इन दोनों ही केसेस में कहीं पे भी रफनेस नहीं आता, कहीं पे भी ब्रेक स्लोप नहीं आता, सिर्फ क्या आता है, चैनल का एरिया, चैनल का टॉप विड्थ, मतलब चैनल ज्योमेट्री पे डिपेंड करेगा ये, है ना, रफनेस पे नहीं करेगा, बेड स्लोप पे नहीं करेगा। इवन फ्राउड नंबर भी लिखा होता है, फ्राउड नंबर पे भी डिपेंड नहीं करेगा, क्योंकि फ्राउड नंबर तो फिक्स होता है। जब फ्लो क्रिटिकल होता है तो फ्राउड नंबर फिक्स होता है, तो फ्राउड नंबर पे कैसे डिपेंड कर जाएगा, है ना। फ्राउड नंबर की जब फिक्स वैल्यू है तो फ्राउड नंबर कुछ भी बदले, क्रिटिकल डेप्थ तो नहीं बदलेगी ना। जैसे हमने देखा था माइल्ड और स्टीप में, माइल्ड में फ्राउड नंबर कुछ और था, माइल्ड में फ्राउड नंबर क्या था, 1 से कम था, तभी फ्लो आपका यहां हो रहा था। स्टीप में फ्राउड नंबर 1 से ज्यादा था तो फ्लो यहां हो रहा था, लेकिन क्रिटिकल डेप्थ की लाइन तो है, वो तो नहीं बदल रही थी ना। तो किसी भी चैनल का फ्राउड नंबर कुछ भी हो, क्रिटिकल डेप्थ की जो हाइट होती है वो सिर्फ डिस्चार्ज और चैनल पैरामीटर पर डिपेंड करती है। डिस्चार्ज भी तो करती ही है, प्लस चैनल की ज्योमेट्री पे भी, रेक्टेंगल है, ट्रायंगल है, क्या है। तो डिस्चार्ज तो लिखा ही हुआ है, गिवन डिस्चार्ज है, तो किस पे डिपेंड करेगी, ज्योमेट्री पे। रेक्टेंगल है तो अलग फॉर्मुला, ट्रायंगल है तो अलग फॉर्मुला, सिर्फ ज्योमेट्री के हिसाब से निकलेगी। उसका ए पार्ट करेक्ट आंसर होगा। ये भी सभी लोगों ने सही आंसर दिया। जो तुम लोगों को नहीं आता है वो तुम लोग देख लेते हो आंसर की में, मुझे सब पता है, मैं देख लिया था, मैं अंधा नहीं हूं, सब पता है मुझे। तो गेट 2011 2 मार्क्स का क्वेश्चन, 2 मार्क्स का क्वेश्चन है। नेक्स्ट 13 क्वेश्चन, क्वेश्चन नंबर 13, इसको सॉल्व करिए। इसके लिए मैं आपको 150 सेकंड का टाइम दूंगा। और क्वेश्चन क्या है, एक स्पिलवे है, स्पिलवे मैंने आपको दिखाया था लास्ट क्लास में, डिस्चार्ज कर रहा है 9 मीटर क्यूब पर सेकंड पर मीटर, मतलब ये स्मॉल क्यूब की वैल्यू है क्योंकि पर मीटर लिखा हुआ है आगे, ठीक है। If the depth of the flow on the horizontal apron is at the toe of the spillway is 46 सेंटीमीटर, डेप्थ ऑफ द फ्लो कितना है, मतलब जब आपका स्पिलवे से पानी नीचे गिर रहा है तो 46 सेंटीमीटर, ये y1 की वैल्यू है। इसके बाद जंप होगा, द टेल वाटर डेप्थ नीडेड टू फॉर्म अ हाइड्रोलिक जंप इज अप्रोक्सीमेटली गिवन बाय विच ऑफ द फॉलोइंग ऑप्शन। तो सिंपल सा कॉन्सेप्ट है, एक क्वेश्चन हमने किया था, आई थिंक पहला ही क्वेश्चन किया था आज, वैसा ही ये भी पूछ रहा है 13, ठीक है। आपको y1 दे दिया 46, डिस्चार्ज दे दिया है, तो ये इवन उससे भी आसान है, ठीक है। तो पोल मैंने क्रिएट कर दिया, आंसर आपको देना है। क्लियर? चलो यार, एक आध को उठा के बाहर पढ़ना ही पड़ेगा क्लास से। ओके, सर्जिकल स्ट्राइक के लिए मैंने बोल दिया, अभी बहुत जल्दी सर्जिकल स्ट्राइक हो जाएगी। चलिए सॉल्व करते हैं। तो y1 आपका 46 सेंटीमीटर है, यानी कि 0.46 मीटर, और डिस्चार्ज आपका है 9 मीटर क्यूब पर सेकंड पर मीटर। यहां से आप F1 निकाल लो, F1 कितना होगा, Q1 अपॉन Q अपॉन अंडर रूट जी y1 क्यूब, और जब F1 आप निकाल लोगे 9 अपॉन अंडर रूट 9.81 इंटू 0.46 का क्यूब, तो यहां से आपको क्या मिल जाएगा, y2 मिल जाएगा, F1 की वैल्यू आ जाएगी, तो y2 बाई y1 का फॉर्मूला लगाना है आपको। सॉरी, ये आ रहा 9.21, if I'm not wrong, it is coming out to be 9.21। तो नियरेस्ट आंसर आपका ये हो जाएगा सी। सर वो क्यू स्क्वायर वाला फॉर्मूला सीधे लगा सकते हैं इसी, हाँ वो भी कर सकते हो, वही बात है। एफ स्क्वायर निकाल लो, यहीं से स्क्वायर करके अंडर रूट हटा दो, वो तो एक ही बात है, इसमें क्या है, कुछ भी लगाओ, आंसर आना चाहिए बस। एफ स्क्वायर इज इक्वल टू क्यू स्क्वायर अपॉन GY1 क्यूब से एफ स्क्वायर भी लगा सकते हैं, उसमें क्या है। हमने सोचा पहले तुम लोग ये बातें कर लो फिर हम आ जाएं, तो हो गई बातें, चलो आगे बढ़ते हैं। अगला क्वेश्चन, क्वेश्चन नंबर 14। The flow in a horizontal frictionless rectangular open channel. The formula we have made, the formula that we have made, that is only for horizontal and frictionless rectangular channel. That formula is not for your triangular channel or any other channel or for channel with friction. We can make the formula. Hydraulic jump happens in channel with friction also. Hydraulic jump happens when in non-rectangular channels also. But we have made the formula only for horizontal frictionless rectangular channel. So whenever it is written, your formula is applicable. Okay. Whenever it is not written, then also your formula is applicable. If any other channel like triangular is given, then formula will be different. If channel with friction is given, then the formula will be different. Okay. If only hydraulic jump is given, nothing is mentioned about friction, horizontal or rectangular, you can apply the same formula. But if it is mentioned that the channel is not rectangular, it is triangular or any other section, then the formula is not applicable. It is given that the section is having friction, then not applicable. It is given channel is having some definite slope, not negligible slope. If a small slope is there, then the formula is applicable. But there is, if large slope is there, the formula is not applicable. That y2 by y1, all the formula of hydraulic jump we have made for these three conditions. Okay. So these are our assumptions also. Whenever we have made the formula of hydraulic jump, these are the assumptions also. Always remember. Assumptions in hydraulic jump. Formulae only. Because basic things will never change. If anything is changing, we have to apply again the momentum equation, energy equation, and continuity equation. We have to make another formula for that. Okay. The channel is supercritical. Okay. A smooth hump is built on the channel floor as the height of hump the water surface width. So this is not the question of your hydraulic jump, but in hydraulic jump also this thing is considered. Okay. In hydraulic jump or channel transition, these are the assumptions. Okay. If these assumptions are not followed, we have to again make the equations. So in supercritical flow, we are making the hump. Now the water surface will increase or reduce, it is asking. Okay. So I'm creating the poll, giving you 90 seconds because this is a very basic question. You can easily solve this question. So giving you only 90 seconds for this, quickly do this question. Quickly do the solution. Because we are having the target of completing 25 questions today. Within 3 hours, we will be completing 25. If more than 25 I'm giving you, so that will be bonus for you. If I'm giving you more than 25, then that will be bonus. At least we are doing 25 questions today. तो बैक एंड से जो लोग परेशान कर रहे थे, मैंने सर्जिकल स्ट्राइक करवा दी है, अब परेशान नहीं करेंगे। अब किसी और आईडी से आएंगे तो फिर सर्जिकल स्ट्राइक होगी, अभी तो करवा दी है। तो सॉल्व करिए, क्विकली गिव मी द आंसर, देन वी विल डिस्कस। सिंपल सी एक बात बताई थी, बस वही आपको दिमाग में रखनी है। Okay, so as I have told you previously, you can see here that if we are doing hump or width contraction, the normal depth will try to move towards the YC, move towards the critical depth. So now what happens when the supercritical flow will move towards the critical thing? So in supercritical, we know in supercritical Yn is less than Yc. So when Yn will try to move towards the Yc, when Yn is less than Yc, so what will happen? In this condition, the flow is supercritical, and we know that the water surface will rise at downstream side. At hump nothing will happen, the flow will rise at the downstream side, hai na? So it will rise not at the hump, rise at a section upstream of the hump. This is absolutely wrong. Okay, drop at a section upstream, this is also wrong. Upstream nothing will happen. Drop after the hump or rise after the hump will be happening, but if after is not given, we can also give at the hump, because just after the hump it is happening, so we can say also at the hump, but everything will happen at the downstream side. At upstream side nothing will happen. Okay, so the rise at the hump is rise at the hump is correct. Sorry, drop at the hump will not be correct, because drop will happen in subcritical. So rise at the hump will be correct. Is it clear? Sir, in these statement type of question, until question में less than critical नहीं बोला तो अपस्ट्रीम में कुछ भी टच नहीं करेगा, राइट? लेस देन क्रिटिकल नहीं बोला, लेस देन क्रिटिकल का मतलब आप डेल्टा जेड मैक्स, मतलब देखो क्रिटिकल, लेस देन क्रिटिकल का मतलब क्रिटिकल डेप्थ होता है। आप कुछ और बोल रहे हो, लिख कुछ और रहे हो, बोल कुछ और रहे हो, लेकिन आपकी फीलिंग में समझ गया। क्रिटिकल कुछ नहीं होता, पहली बात। क्रिटिकल जो आप बोल रहे हो ना, उसको हम क्रिटिकल नहीं बोलते हैं, गलत शब्द मत बोलो। जो आप बोल रहे हो उसको हम मैक्सिमम हाइट ऑफ हम्प, अगर हम्प बनाया है और अगर हमने विड्थ कॉन्ट्रैक्शन किया है तो उसको हम मिनिमम विड्थ बोलते हैं। क्रिटिकल मत बोलो, क्रिटिकल डेप्थ से कंफ्यूज हो जाओगे, क्योंकि क्रिटिकल डेप्थ बनती है, ठीक है। वो बात अलग है कि मैक्सिमम हम बनाए और चाहे हम मिनिमम विड्थ ऑफ कॉन्ट्रैक्शन करें, उस पर क्रिटिकल डेप्थ ऑफ फ्लो होता है। तो क्रिटिकल डेप्थ ऑफ फ्लो होता है, उसको उस कंडीशन से कवर मत करो, ठीक है, पहली चीज, ठीक है। सेकेंड थिंग इज दैट कि जब तक हमें कुछ बोला नहीं गया है कि चोक कंडीशन आई है नहीं आई है, ओके सर, इंग्लिश, आई फॉरगॉट इंग्लिश, सॉरी, sometimes I forgot English, so I'm really sorry that I forget English. It is, please take my deep apology. So let me repeat this, because he was asking the things in Hindi, na, that was also I was replying in Hindi, so please take my sincere apologies, okay, because he was asking in Hindi, so I replied him in Hindi, but no worries, this is a protocol, so we need to follow the protocol, okay, because in English class we have to teach in English, but if somebody is asking in Hindi, na, so how can I reply in English? That is why I was replying in Hindi. This was the main thing, because he was asking in Hindi. Suppose we have gone to a hotel and some waiter or some door person is trying to talk to me in his language, so I will try to speak in his language if I know. If he's asking me in Hindi or Telugu or any language and I'm replying in English, that is generally not the case. So he was asking in Hindi, that is why I was replying in Hindi. Okay, no issue. So I will follow the protocol, dear, what I will say, dear sir. So allow me first reply him in Hindi, then I will reply in English. I was doing the same thing, but you guys are giving the order, okay? So don't break the flow of the teacher. Don't try to, because sometimes I use Hindi, but it should be my discretion na, because if somebody is asking in Hindi, I should respond as per his definitely I will be repeating the things in English. So until and unless you are not given any choked condition, you do not have to follow that. Now let's move to the next question. Question number 15. A trapezoidal channel is 10 meter wide at the base and has a side slope of 4 horizontal to 3 vertical. The bed slope is 0.002. The channel is lined with smooth concrete, Manning's N 0.012. The hydraulic radius in meter for the depth of the flow 3 meter is. So conversely, here you have to just go through the question and just fetch me the correct things, whatever is suitable for this question. Just give me that in the poll. So in the previous question, what we have got the D part as the correct answer. So we have reached 71% of the probable correct answers. Now in the next question, what we are going to do, we are going to have again the poll for this. So just I have started the poll, and now you need to give me the answer quickly. This was our question number 15 and previously it was 14. So let's continue. So again, I have given you some time for this, and I think that you will be solving this question. So a trapezoidal channel is given and 10 meter width is given. The base and the side slopes are also given. So this question will be solved using your Manning's formula. The simple thing is that the hydraulic radius is asked, width is given, side slope is given, but depth of the flow is not given. So we have to just apply the Manning's formula to get the depth of flow is also given. So why they have given you the Manning's N? I don't think that the Manning's N is required here. Just we have to calculate the area. Area is B plus my into y. So 10 plus m is 4 horizontal upon 3 vertical into y into 3. It will be 42 meter square. Perimeter is b plus 2y root m square plus 1. That is 10 plus 2 into 3 into 4 by 3 whole square plus 1, that we will calculate. %, students have given the correct answer. Next question, question number 16. A rectangular open channel flow of width 5 meter is carrying the discharge of 100 meter cube per second. The Froude number is given as 0.8. The depth of the flow in meter is. So this is the same question we have done in where we have calculated the critical depth. Now we are going to calculate the depth of the flow in the uniform flow. So what happens if R is equal to, you know that the formula of Froude number is equal to Q square upon or Q upon G y cube. So we can apply this formula. Discharge is given, so we will write down the discharge. 100 upon width 5, this is Q value, you know this thing, and upon under root g y cube, g is 9.81 into y cube, y you have to calculate, okay, and this value of crowd number is 0.8. So from here we will calculate the value of y and calculate. I'm creating the poll for you. So please solve this quickly and give me the answer. Purohit, you cannot speak the language which is not understandable to others. You need to speak in English as per the student's request. So because this is the gate wala English channel na, so it is convenient for others to understand English. That is why I'm only saying. In Hindi channel we generally discuss everything in Hindi. So some students are not able to understand Hindi na, so please write down in English, because some students are continuously saying English. Okay. So quickly tell me. Please try to speak in English, because write down in English, because some students are not able to understand Hindi. Quickly give me the answer. Quickly. Okay guys, let's do the solution. So we are getting 4 meter as the correct answer. So A is the correct answer. Next question, question number 17. For subcritical flow in an open channel, the control section for gradually varied flow profile is. For subcritical flow, where is the control section? When you will throw the stone, the wave will travel aside, and the opposite side will be the control section. Wherever in which direction the wave is traveling, the opposite side is control section. This is very simple. Only 60 seconds you need, so I'm creating the poll. You can give me the answer within 60 seconds. So in a subcritical flow, when you are throwing the stone at this section, this is upstream side, this is downstream side. So the wave will travel this side. This is VW. So here, if any observer is standing, so what he will feel? The wave is coming from its downstream side. Okay. So this is the control section. So control section is situated where? If some observer is standing here, it is saying the control section is at the downstream side of the flow, because this is the velocity of wave flow. So here the observer, when it will see the wave, it will say that the wave is coming from the downstream side. So the control section is at the downstream end. Okay. For any gradually varied flow or any flow, control section is at downstream side. That is why in subcritical flows, before the disturbance at this side the flow profile occurs. Flow profile occurs before the disturbance. That is why, because wave travels there. Okay, next question. Let's move towards the next question. This question, this is asked in GATE 2017. Why they have blurred it? Don't know why they have blurred it. GATE 2017, it has been asked for 2 marks. So a 1 meter wide rectangular channel has bed slope of 0.016 and manic roughness coefficient is 0.04. Uniform flow takes place in the channel at a flow depth of 0.5 meter. This is uniform flow depth. At a particular section, GVF is observed and the flow depth is 0.6 meter. So GVF is having more than the uniform flow depth. Now GVF profile is asked at the section. So Y is more than Yn, but if it is more than Yc or if it is more than less than Yc, we have to check. Then depending upon S1, S2 or M1, M2 profile will be there. So first check whether the bed slope the flow is above critical flow or below critical flow, then you will get the bed slope also, then you will get the profile also. So I'm creating the poll, giving you 150 seconds because it will take time. Give me the answer. Quickly give me the answer. I'm coming in 2 minutes. This will be your question number 18. Everybody is saying C part as the correct answer. Let's see. So Yn we know 0.5 meter. Y we know 0.6 meter, means the flow is varying below the NDL value. Now let's calculate the YC value. How to calculate YC? First of all, let's calculate the discharge in this channel. Let's calculate discharge Q. So Q will be equal to 1 upon N into area into R raised to power 2 by 3 into SB raised to power 1 by 2. So Q is equal to 1 upon 0.04 into 1 into depth of flow is 0.5. R will be equal to 1 into 0.5 upon 1 plus 2 into 0.5. Area upon perimeter raised to power 2 by 3 and 0.0016 under root 0.0016. So discharge will be here how much? What will the discharge? Let us check. How much this is coming? 0.1984. So discharge per meter width, that will also be 0.1984 because B is 1 meter. Meter square per second. So YC will be equal to how much? 0.1984 square upon 9.81 raised to the power 1 by 3. .16 meter. So it is YC we have calculated 0.16 meter. So whenever we will make the channel, so this is your channel, then first CDL will come. Why CDL will come? Because YC is lesser. Then YN will come, means NDL will come. This is YN. Okay, now here this is the reason 1, this is the reason 2, this is the reason 3. Okay, So NDL is above CDL, means the slope is mild, because in mild slope this happens. Next thing, your YN is where? Your YN is 0.6, means it is above here, above YN. Your depth of flow is happening here. Okay, depth of flow is happening here. So it is happening like this, because in region 1 the flow increases. So it is happening here. So whenever it is happening here in mild slope, so it will be M1 profile. So the correct answer will be C part. Are you getting my point? Y is more than YN and YC both, so it will be M1 profile. So the correct answer of this question will be C part. Okay. Now let's move to the next question. This is the question, please solve it. I'm creating the poll, integer type poll I'm creating. Solve it and give me the answer. Okay, let's solve this. We have taken a lot of time for this. A sluice gate used to control the flow of the horizontal channel of unit width is shown in the figure. Okay, width is unit 1 meter depth here, and now 0.2 meter depth is here. But where is the hydraulic jump? Let's see. It is written in ahead. It is observed that depth of the flow is 1 meter upstream of the gate and wide the gate is 0.2 meter downstream of the gate. Assuming the smooth flow of the transition across the sluice gate without any energy loss and the acceleration due to gravity as 10 meter per second square, g you have to take 10 meter per second square, the discharge in meter cube per second up to 2 decimal places passing under the sluice gate is, the discharge is asked here. So this discharge passing is asked here. Okay, so some students are saying 0.816, some are saying 0.81, some are saying 0.82. First of all, let me tell you, only you have to give the answer in 2 digits after decimal. So the answer correct will be 0.82. Okay, but some students are also giving 0.77, some students are also given 1.09. So let us see what is the correct answer here. So the channel is horizontal, width is unit. So what we will do, we will apply 2 equations. Either we can apply the continuity equation, or we can apply the momentum equation, or we can apply the energy equation. Any 2 equation we can take. But for the energy equation, we also need for the energy equation we will also need your all the heads. So what we will do, we will apply only 2 equations here. First is A1 V1 is equal to A2 V2. 1.2 okay, A1 V1 is equal to A2 V2. So from here we will get 1 into 1 is the area here, 1 width depth 1 into V1 is equal to here area 1 into 0.2 into V2. So from here we have got V1 is equal to 0.2 V2. Okay, V1 is equal to 0.2 V2. Okay, next formula we will apply. सर E1 is equal to A2, हाँ वहां से भी कर सकते हैं, बट उसके लिए हमें V1 और V2 में रिलेशन पता होना चाहिए ना, वो तो यहीं से आएगा. Okay, so we can do E1 is equal to V2, but we need to have a V1 relation between V1 and V2. So from that we need to take. Okay, I'm again saying everybody need to ask everything in English, because if you're asking in Hindi, naturally I have my essence that I will reply in Hindi. So this is English batch, so please concentrate this thing. Now, if we will equate the energy here, so Y1 E1 is equal to E2. So Y1 plus V1 square by 2G is equal to Y2 plus V2 square by 2G. So Y1 is given as 1 meter. So 1 plus V1 is 0.2 V2, so 0.2 V2 square upon 2G is equal to Y2 is 0.2 plus V2 square upon 2G. So from here we will put G is equal to 10 because G is given as 10. So from here we will get the value of V2. So what is V2 here? We will get this. $4.0825. Is it correct? Please check. Is it correct? Please check. Now Q will be equal to A2 V2 or A1 V1, we can do anything. A2 V2 will be equal to 0.2 into 1 into V2, 4.0825. It is 0.8165 meter cube per second. The correct answer will be 0.82. Is it clear? 71% have given the correct answer. This is the leaderboard. Swagatam, Vinay, Ritika, Suraj, Yusuf, and overall 34 students are given the correct answer. Okay, so this was the question number 19. This is question number 20. A 1 meter wide rectangular channel carries a discharge of 2 meter cube per second. A specific energy depth diagram is prepared for the channel. It is observed that in this diagram, the corresponding to a specific energy, the subcritical depth is twice the supercritical depth. So for any specific energy, the subcritical depth and supercritical depth are the, what are they? They are alternative depth. Okay. So they have asked the subcritical depth in meters up to 2 decimal places. So you have to apply the formula of 2y1 square y2 square upon y1 plus y2 is equal to q square by g. This is the formula for alternate depths. For alternate depth, this is the formula. And for sequent depth, q square by g is equal to y1 y2 into y1 plus y2 by 2. This is for alternate depth. Okay, so always remember the formula are different for alternate depth and for sequent depth. For hydraulic jump, the relation is different. Because in hydraulic jump, the specific energy are not equal. There is a loss in specific energy. For alternate depth, there is no loss in specific energy. Both specific energy are equal for y1 and for y2. So this is the difference between alternate depth and sequent depth. In hydraulic jump, y1 and y2, in hydraulic jump, sequent depth, do not have specific energy same. There is a loss in specific energy, that is called head loss, EL. And in alternate depths, both the specific energy are same for y1 and y2. Okay, so if somebody is asking the difference between alternate depth and sequent depth, you can tell me. You can tell them. Okay, so give me the answer in meter up to 2 decimal places. I'm creating the integer type pole. 150 second is there. So give me the answer quickly. You have to apply this formula. You will have a quadratic equation. Solve that quadratic equation. You will get two values. The smaller one is the subcritical. The greater one is the subcritical depth. The smaller one is supercritical. Subcritical is asked, so you have to give the greater value. Okay, everybody has calculated 1.07. I don't think I need to calculate, but just let me solve the things. So let us take y1 is equal to y. So subcritical depth y2 will be equal to 2y. So we are taking y1 as y and y2 is equal to 2y. So what will happen when we will write down these things? 2 into y square into 2y square upon y plus 2y is equal to q square by g. What is q square? 2 meter cube per second. So 2 divided by 1 is square divided by, what is g we have to take? 10 or 9.81. G is not given here, so we will take 9.81. So from here, let us check what is the value coming out to be. I don't have my calculator. Let us first check. So 2y square into 4, it will be 8y raised to power 4 upon 3y is equal to 4 upon 9.81. Am I right? So this will be cancelling out. So we will get the value of, so no quadratic equation is there. This is very simple. So y will be equal to 3 upon 9.81 raised to the power 1 by 3. So what is the value we are getting here? Let me use with the calculator. Let me calculate with this with the calculator. So I'm calculating, this value is coming out to be 0.636734 6737 meter. So this is y1. y2 will be double of that. So y2 will be 2y 1.34 7 meter. 1.347, we have to give answer 2 decimal places, so 1.35 we will give the answer. You guys are calculating 1.07. I have done any mistake? 2 into y square into 2y square, so 2y square 4, 4 into 2 8, 2 4, okay, 3y. So 3 upon 9.81 raised to the power 1 by 3. 0.6737 into 2. It is coming out to be 2, where 2? 2 by 3. Okay. Okay, I got here. Here it is 2. So it will be 3 by 2. Okay. This is the answer of this question. This was the question number 20. Let's move to the next question. Question number 21. GATE 2018, 1 mark. 10 meter wide rectangular channel carries discharge of 20 meter cube per second. This is 10 meter wide channel. And under critical condition, G is equal to 9.81. The specific energy is asked. So this is a very simple question. I will just give you 90 seconds. This is a very easy question. You can easily solve this. Solve this question quickly. So somebody is saying 1.11, somebody is saying 1.12. So I'm creating the NAT poll for this because by mistake I have done this poll. So integer type poll for 60 seconds. Now I'm giving 60 seconds. Quickly give me the answer. The specific energy will be how much? E will be equal to y plus v square by 2g. Or we can say y plus q square divided by 2ga square. Because velocity is discharged by area. So E is equal to depth of flow is how much? Depth of flow is critical. So critical we have to first calculate. So y is equal to yc, that is q square by g raised to power 1 by 3. So that is, what is q? 20 by 10 whole square divided by 9.81 whole power 1 by 3. First let's calculate this value. And when y is equal to yc, we do not need this formula. We do not need formula. When y is equal to yc, we can directly say E is equal to E minimum at y is equal to yc. So we can directly 1.5 into yc put. We can put directly this thing. This is coming out to be 0.7415 meter. This will be 1.5 into 0.7415. So 1.112 meter. The correct answer 1.11. 2 digits after decimal it is asked, na? Yes. So 1.11 is the correct one. Okay, very good. So overall, Swagatam, Vinay, Ritika, Suraj, Yusuf, top 5 are there. Total, how many students? 36 students are giving the answer. Next question, question number 22. This is MCQ type. 4 options are given there. So 70 meter cube per second per meter width is the discharge. 70 meter cube per meter width it is given. So if it is given capital Q, but it is per meter width, na, so it is actually small q. Whether it is written capital Q or small q, if it is written meter cube per second per meter width, na, so it is actually small q. It is the discharge per meter width. Whether it is written capital Q or not. Whether it is written capital Q or small q. So very wide rectangular channel. For very wide rectangular channel, what happens? The hydraulic mean radius is nearly equal to depth of the flow. R is nearly equal to y. Carries discharge of 70 meter cube per second. Bed slope is changing from this to this, means bed slope is increasing at point P. So here the bed slope is 0.001, here it is 0.009. So let us check whether this is steep or this is mild, which slope is mild, which is steep, anything is critical, or they are like this. So for that we have to calculate the critical slope. What is the critical slope? We will calculate. Okay. Now the figure is not to the scale. The Manning's N is 0.01. What is the water profile near the point P? So near point P, what will the water profile? M2, S2, M2 only, S2, S2 and hydraulic jump. So first you have to calculate the critical slope. At y is equal to yc, what is the slope? First calculate this. Okay, so this is a very good question. I will be giving you more than 2 minutes here. So I'm giving you more than 2 minutes here. Just solve and give me the answer. I will be ending the poll after 4 minutes, 3 to 4 minutes. So solve this question and then I will be ending the poll. I have skipped some question in between. In between, I have deliberately skipped some question because there are more than 40-45 questions. So remaining questions, whatever the questions are remaining, I will be giving those questions to you in the next class at 7 p.m. in GATE wala ME, CE, XE and CH channel. So don't worry, 25 questions we have done today, right now, and the remaining 20-25 questions we will be doing in the next class at 7 p.m. So don't worry about that. All this, quickly give me the answer. I will be solving all the questions of profile, no worry. In this class also and in the upcoming class also, don't worry. I will be solving this question in front of you. I will be making the profiles, don't worry. And that is why I have given you unlimited time here. Whenever you get the answer, then you have to give me the answer. Don't do hurry, or don't be in a very hurry in solving this question. Whenever you have got the answer, then you can give me the answer. Okay, let's see. First of all, let us see whether the slope is mild or not. So what we will see, what we'll do, we will first calculate YC. So YC will be equal to how much? 70 is the discharge per meter width upon 9.81 raised to power 1 by 3. I think we have to take G as 9.81 because D is not given here. Yes, G is not given. So this is coming out to be how much? This is coming out to be how much? 7.934. So let me first end the poll because I think all of you have given the answer. Let me first end the poll. Okay. Yes. Now, what we will do, we will calculate at y is equal to yc, what is the bed slope. So Q is equal to 1 upon n into A into R raised to power 2 by 3 into SB raised to power 1 by 2. But for the critical slope, if we will write down Q upon B, so this will be equal to, discharge will be equal to 70 into width B, because 70 is the discharge per meter width. So total discharge 70 into B is equal to 1 upon n is how much? 0.01. Area is B into Y. What is the depth of the flow? Depth of the flow is given. Yes, depth of the flow we have calculated here 7.934. At critical, when the flow is critical, R, because very wide rectangular channel, we can write down R is equal to Y, 2 by 3. SB will be critical slope because we have put Y is equal to YC. So SB will be SC, critical slope. So from here, this B and B will cancel out. We'll calculate SC. .9, we can write down as 0.00 0.0492. So critical slope 0.0001. So SB1 is 0.0001. So this is lesser than SC. The slope is mild. First slope is mild. And SB2 is equal to 0.0009. Yes, 0.0009. This is greater than SC. So this is steep. First of all, this is clear. First of all, this is clear. Okay, so let's make the lines first. This is your CDL. This is again your CDL. This is your normal depth line in mild, and this is your normal depth line in steep. This slope is mild. This slope is steep. Okay. Now let's see what is the profile. This is 1. This is 2. This is 3. This is 1. This is 2. This is 3. So always remember the flow will go to the NDL, this NDL, and then the flow will also start from NDL. NDL to NDL the flow will go. So first it will drop like this, and then it will again drop like this. So here it is in region 2, so M2. Here it is also in region 2, so S2. So M2, S2 will be the profile. A part is the correct answer. So just you have to identify what is the slope. This is the mild slope, this is the steep slope. Now we got what is the slope, then we can make the profile. This was simple when we got that what is the slope. So 90% are given the correct answer. But the giving the correct answer is not important. Important is how to solve the question and what are the variations here. So when you know which slope is meeting which slope, you can give the answer. Now let's move to the next question. That was question number 22, sorry. That was question number 22. Now we are moving towards the question number 23. This is your question number 23. A hydraulic jump occurs 1 meter wide rectangular channel, frictionless. Pre-jump depth is 0.2 and post-jump depth is 1. The value of G may be taken as 10. The values of a specific force at the pre-jump and the post-jump sections are the same and equal to how much? So in hydraulic jump, what happens? The specific energy is not same, but the specific force is same at both sections. And what is the formula of a specific force? I have given you the formula in the last class. A into y bar plus q square by ga. You have to calculate this thing only. Q square by ga. But how to calculate? We know the g value. We will also know the area. We will also know the y bar. But how to calculate the discharge? For calculating the discharge, you have one more formula. What is the formula? The formula you have q square by g is equal to y1 y2 into y1 plus y2 y2. But sir, you have given the different formula of y1 y2 in some question in the previous question. You have given this formula. You have given this formula in the previous question. So this is for alternate depth. This is for alternate depth. This is not for hydraulic jump. For alternate depths, this is the formula. Alternate depth are having specific energy equal. But this formula I have given you for sequent depth or conjugate depth. In hydraulic jump, this formula is applicable. And here specific energy are not equal. Here only specific force is equal. So please remember that there are two formulas. One for conjugate depth, one for alternate depth. Alternate depths have specific energy equal. Conjugate depth have specific force equal. Specific energy are not equal here. So first calculate Q. You know y1 by 2. First calculate Q and put here. Or calculate Q square by G. We can write it down like this also, na? A into y bar plus Q square upon Q square into A upon G. Because discharge will be equal to how much? Now Q square. No, this will not be there. First calculate Q square, then we can put this value here. First calculate Q square, then we can put this value here. So solve this and give me the answer. In the last class, somebody was asking, sir, what is the unit of specific force? Write down, please check here. It is written in meter cube. Okay. In the GATE question, 2023, 2 years back, they have given the unit. Okay. So don't worry, whatever I have told you, you can always be relied on that. So solve this question. After that, we will be solving 2 more questions because I have told you that we will be solving 25 questions today. After this question, we will be solving 2 more questions. First solve this. This is a very good question. Solve this, then we will be moving further. Your poll has started. You can give me the answer. Integer type poll is started. No. Just give me a minute. I will be ending the poll. Integer type poll is started now. Now you can give me the answer. Bharat Pathak, you can give me the answer again because I have changed the poll. So please give me the answer again. Okay guys, let's see the solution of this question. Some of you are saying 0.62. Let's see whether the correct answer is there or not. So what we have to do, we have to just first calculate Q. So Q is square upon 9.81. That is equal to how much? Y1, Y2. Y1 is 0.2 and Y2 is 1. So 0.2 into 1, 0.2 plus 1 upon 2. So from here we will get the value of Q. As width is 1 meter, so Q and small q and capital Q will be same. .085. That is Q upon 1, which means Q is equal to 1.085 meter cube per second. Yes. Now we will put this value here. So F will be equal to A into Y bar. So area is from any point we can calculate. Let's calculate at depth 1 meter because it is easy to calculate us at 1 meter. So 1 into 1 into Y bar. Y bar will be equal to depth by 2, 1 by 2 plus Q square by GA. So 1.085 square divided by GA. G is 9.81. Area is again 1. So from here we will get the value. It is 0.62 meter cube. Actually, the unit of this is Newton upon Newton per meter cube, but we can directly write down as meter cube. 0.62 will be the answer. Okay, 50% students have given the answer. This is the leaderboard. Swagatam, Suraj, Vinay, Ritika, Yusuf, and overall 36 students are giving the answer. Let's move to the question number 24, the second last question. A compound symmetric open channel section as shown in the figure has maximum critical depth. So this is your channel. This width is BF, this is BM, this is BF, and the factor here is NF. So what will be the critical depth of this channel? 3, 1, 2, 4. How many critical depth is possible for this? Q bar, explain. What is Q bar? What is Q bar? No, nothing is Q bar here. Where Q bar I have used? This is Y bar. Y bar is the center. In the last class yesterday in theory I have told you, Y bar is the center. Center. Okay, so the answer of this question will be how much? 0.62. Now let's create a poll for this question. 150 seconds I am giving you the poll. 150 seconds I am giving you. Now tell me the answer. Maximum critical depth it is asking, okay? Maximum critical depth. Y bar is the center of the area of the flow. In rectangular section, the center of the area from top is y by 2. Y bar is the distance of center of area. Suppose this is the channel, the center is here, center of area from top is y bar. In the last class I have told you this thing. For triangular it is y by 3. For any channel we can calculate the centroid, the center of area. Calculate this. So what will be the answer? A, B, C, D? Quickly tell me. What will be the answer of this question? Quickly tell me. How many critical depths are possible? Quickly tell me. So whenever the channel will change its characteristic now, then your new critical depth may be possible. So how many times it is changing its characteristic? Tell me. So it is changing its characteristic 2 times. First, initially the depth of flow will be like this. So there will be one critical flow possible here. One critical flow is possible. Okay. 2 times it is changing, 2 times. First, this is the condition. Then now here it is changing its characteristic. Here, because after this it is changing its characteristic. So here it is also changing characteristic. So here it is flowing again. There will be different conditions. And above this when it will move again, so again the characteristic will change, because up to here it is changing up to rectangular. Above this it will change rectangular plus this composite section, this wide channel, and this channel will also be included. So what will happen above this side boundary will also come in picture. So this will give also the friction. So here 3 times or 2 times it will change. So first this is the one critical depth, 2 times it is changing plus 2, so the answer will be 3. 3 it may change. 2 times it is changing its characteristic, so plus 1 more will be the critical depth, because at the last when it is increasing it will also have one more critical depth. So overall 3 critical depth is there. 91% have given the correct answer. Very good. Next, last question for today's class. The critical flow condition of a channel is given by alpha is the kinetic energy correction factor, Q is the discharge. This was asked in 2023 for 2 marks. AC is the cross section area of the flow, and TC is the top width of the flow. Critical flow condition, G is the acceleration due to gravity. The same question has been also asked in 2024. Same question and also similar question where alpha is used, kinetic energy correction factor is used. Similar question has been asked in 2024 also. I will show you that question if I have. So they are asking that what is the relation between these things. So we know that the relation is Q squared T by GA cube is equal to 1. We know this thing, but here we are considering alpha is equal to 1. But if alpha is not 1 now, then alpha will also come here. And how we have made this equation? By putting FR square is equal to 1. Froude number is equal to 1 for critical flow. If we will do FR square, then also it will be equal to 1. So when we will put FR na, Q upon A divided by root GD, so that this thing will come. When we will put FR is equal to, FR is how much? Q upon A, that is discharge upon area velocity, upon root GD. D is A by T is equal to 1. This is FR is equal to 1. And if we will do FR square is equal to 1, so what will happen? So from here we will get this square, Q square upon A square upon GA by T is equal to 1. So from here we will get, what is the thing we will get? Q square T by GA cube is equal to 1, because this A square will come down and T will come up. From here we have got this. So for critical flow this is the condition. But when the alpha is 1, if alpha is not 1, we have to put alpha also in equation. How we will put the alpha in equation, that is the question. So I'm creating the poll, again giving you 150 seconds. Give me the answer. This is the last question for today, that I have told you that I will solve 25 questions today. This is the last question for you. So quickly give me the answer. Okay guys, let's see. I have told you that when alpha is there, your kinetic energy correction factor is there. So here, when alpha is present, what we will say that kinetic energy is Ke is equal to alpha into half rho AV square. Kinetic energy is alpha into half rho AV square, because if alpha is 1, that will be 1 into half rho AV square. But if half rho AV cube, not a square, half rho AV cube, because rho AV is the mass and V square is also there. So this is the kinetic energy. Now what is the kinetic head? Kinetic head, that is kinetic energy upon weight, that is alpha V square by 2g. And from that, if we will calculate the Froude number, so what will the Froude number? Froude number square will be equal to alpha V square divided by g into d. Alpha V square divided by g into d, because Fr square is connected with the kinetic energy. Froude number is also connected with the kinetic energy. Yes or no? Kinetic head is connected with the kinetic energy, na? Yes or no? Okay. So alpha V square divided by g, that is the Froude number if alpha is there. So if Froude number square is alpha V square by gd, so we can write it down as alpha into q square divided by a square upon g into a by t, or we can write it down as alpha q square into t divided by ga cube. This Froude number. And for your critical flow, this value will be equal to 1. Alpha q square t upon ga cube is equal to 1. So always remember only one thing, whenever you have to use alpha, so wherever v square is there, put alpha with this. Wherever v is there, put root alpha with this. So if alpha is not 1, everywhere where you are using velocity, put root alpha there. Everywhere we are using v square, put alpha multiplied by that. So v square is multiplied by alpha if alpha is not 1, or v is multiplied by root alpha if alpha is not 1. Because one more question has been asked in the next year, GATE 2024. They have asked the specific energy, but the trick was, or the click was, they have given alpha as 1.1. So what is the specific energy? The specific energy is actually y plus v square by 2g. So that will be y plus alpha v square by 2g. Alpha will be there. Okay. So wherever alpha v square is there, you have to just multiply it by alpha if alpha is not 1. So alpha q square t by ga cube is equal to 1 for critical flow. So we will write down this thing. So for critical flow, alpha q square into t will be tc, because flow is critical, upon g into ac cube is equal to 1. That is the Fr square also if alpha is there. So now what we will do, alpha q square upon g, that will be equal to ac cube upon tc. This will be the answer. So ac cube upon tc, alpha q square upon g, ac cube upon tc. Here square should be there. I don't know why square is not there. Here square should be there. They have missed writing down a square. So I am not giving the answer of this poll. I am stopping this poll, and the answer will be D part, because none of these was the answer. But the nearest possible is this. Here they have put down. Here they have missed to write this q square. Okay, or I can give the answer D part, because I need to end the poll now. So Swagatam, Suraj, Vinay, Yusuf, Ritika, they are the top 5 students, and overall 37 students are giving the answer. Let me reiterate who are the top 10 students. So Swagatam, Suraj, Vinay, Yusuf, Ritika, Manoj, Sarvagya, Nitin, Akansha and Sunil, they are the top 10 students. Now if you want to join my Telegram group, if you have not joined yet, join my Telegram group by searching Shobhit Sir PW in Telegram. And at 7 PM we also have one session. We will be solving more questions. Some questions we are not able to solve today because time was not there, and we have more than 40 questions. So those questions we will solve in the next session. 7 p.m. at gate wala MEXZ and CH channel. So thank you guys. Now we will meet in the next class. Bye bye. Take care. Jai Hind. Sir, please explain question number 24 once. Let's explain question number 24 once. This, when it is increasing, here there is only one cross section, one YC. Where it is reaching here, it is reaching here. So side boundary, this boundary has started giving friction there. So it will not quickly move towards the above height. Here, because it is friction there, na, so the discharge will be more, discharge will be increasing to overcome this friction. So here there will also be one YC, and when it will increase from here, it will move towards this. Then again one YC will be here. So one YC will be here, YC1. One YC when it is overcoming this friction, that will be critical here, and one YC when it is going up, YC3. Clear? Because both friction at both sides has come suddenly, so it will also give friction YC here. So this is the thing. Now we will meet in the next class. Thank you guys for joining. Bye bye. Take care. Jai Hind.